Okay, good. So this is okay. So this is like power, and when I select this and then I run it, you get square root of 5, which is 2.23, right? So these are called as arithmetic operators. These are the operations that we perform on numbers, right? We can't perform arithmetic operators on text data, right? So we perform only on numeric data or the numbers. So here the input, right, that we give is also numeric, like 3 plus 5 or 5 to the power 5 raised to 0.5. Okay, these are numbers, right? So operators uses input as numbers and output is also a number, right? Okay. Or what we call as numeric in R, right? Numbers we call numeric in R. So we'll try to speak R language itself. So the arithmetic operator takes numeric as input and gives numeric as output. Then we discussed about relational operators. Okay, relational operators is used to check the relation. Okay, is used to check operations. Okay, and what were the operators that we discussed?
Didn't we do and?
Sorry, no, we haven't done and yet. We'll do in some time. Okay, today that's the topic for today. So relational operators is to check the relationship between two variables, two numbers. Okay, so here the input is also number, but output is either true or false. It's like asking question, is number greater than or is number less than? Okay, so if I say greater than, it's like asking, is number greater than? Okay, so if I say print 10 greater than 4, so is 10 greater than 4? That's what it means. Okay, it takes input as numbers, but answer will be either true or false, right? So what do you think answer would be here?
True.
True, yes, because 10 is greater than 4, right? So it's like asking question, is 10 greater than 4? And answer is yes, 10 is greater than 4. So the output, if I run it, it will be true, right? So similarly, you can check less than, right? You can check greater than equal to, okay? You can check for less than equal to. You can check for equal to equal to. See, equal to is for assignment. A equal to 5. That means I'm saying assign value 5 to A. Okay, double equal to is to check are two values equal. So if I say 10 equal to 4, so it's like asking, is 10 equal to 4? Answer is obviously no, right? So when you run it, you get false, right? You see, you get false here. If I make it as 10, then of course 10 is equal to 10 and you get answer as true. And you have something called as exclamation and equal to. This is sign for not equal to. Is 10 not equal to 10? Okay, answer is false because 10 is equal to 10, right? So you get false. So these are the two operators that we discussed yesterday. Now we will talk about logical operators. Logical operators. Okay. So what is logic? Okay. What are different operations that we perform in logic? Okay. So I'm going to ask you a question, okay, and then we'll talk about this. Let's say I say Sachin and Sehwag will open the batting. Okay, if you don't understand cricket, that's okay. What I'm saying, Sachin and Sehwag will do something. Okay, and actually, so this is what I'm predicting. In actual, what happened was Sachin and Rahul opened the batting. Now tell me, my prediction, is it right or wrong? Did I predict correctly or incorrectly?
No, it's wrong.
My prediction is wrong.
Wrong.
Okay. Now let's say I'll make a small change in this. So I'm predicting now Sachin or Sehwag will open the batting. I'm saying Sachin or Sehwag will open the batting. Actually, Sachin and Rahul opened the batting. Now, if my prediction is correct or wrong?
This one is correct.
This one is correct. Okay, so logically, if you think, okay, these are logical statements, right? So you have to think logically, and then we'll see mathematically how we do it. Okay, I'm not sure if Keshman and Gauri, you have gone through this class in your school, but here what happens is when you put and, okay, I'm going to do this, and I'm going to do that. That means you're taking commitment for both, isn't it? So I'm going to do this and I'm going to do that. That means you're taking commitment for both. And even if you don't do one, or you do one, you don't do one, still it will be called as that you have not fulfilled your commitment, because you promised to do both, you did only one. Okay, so it is you have not fulfilled it. Okay, so it is as good as not doing it. Whether you do one or you do none, it is still you have not done it. Okay, now if you say I'm going to do this or I'm going to do that, I'm going to do this or I'm going to do that, that means you are taking responsibility of just one of the two, right? You are not taking responsibility for both. So even if you do both, it's fine. Nobody's going to fine you for that. It's fine. But if you do one, also it's fine, because you have committed only for one. You're not promising for both. So, okay. So what we do is, okay, if you take input, okay, true means that you get it right, and you say and true. That means I'm going to do this is true, and I'm going to do that is also true. That means you have fulfilled commitment. Answer will be true. But you are saying that I'm going to do this, you did not do it, so false. I'm going to do that and you did not do it. Both you did not do it, it will be false. Right? Now, I'm going to do this, you did it. I'm going to do that, okay, you did not do it. Did not is false, right? I'm going to do this, I did it. I'm going to do that, I did not do it. Okay, it will still be false. Did you get this?
Yeah.
Yes.
Okay, you are making commitment for both. You have to do both. You make commitment for 10 things. You have to do all the 10 things to get the credit. If your commitment for 10 and you do 9, it is as good as doing nothing. You won't get a credit because you're committed for all, so you have to do all. But when you do or, it's like either, right? Either this or that. You are not taking commitment for both. So I will do this and you did it. Okay, and let's say this is the sign of or. Okay, I'm going to do that and you did it. Very good. So you get commitment, even though committed for one, but still you did all. You still it is. Okay. Yeah. Okay. So this is what we're talking about, right? So if you say commit for this or that, and both you did it, it will be true. Okay, you commit for this and you did not do it, or I will do that, you did it, it is still true. That means you have met your commitment. Similarly, okay, it is true. If you say I will do this and you did not do it, or I will do that and you did not do it, it is false. That means you have not met your commitment. So that is the difference between and or. Okay, and or. So these are called logical operators. And or are called logical operators. Two logic, two conditions, you put it together. Okay, so how do we use it? Let's take an example. I'm saying print 10 greater than 5. It will be true or false?
So it will be true.
It will be true, isn't it? Because 10 is greater than 5. Okay, and then I give and I say 5 not equal to 5. So see, the logical operator takes either true or false logical input and it gives you logical output. Okay, so like arithmetic takes numbers and gives numbers, numeric and gives numeric. Logical operators takes logical values is 2, right? Binary, true or false. So it takes either true or false and gives us true or false. So 10 greater than 5 is true and 5 not equal to 5 is false. True and false will give us false, and you see you get false here. And if I do OR here and when I run it, it will give true. This is true and this is false. True or false is true, right? We call that as truth table. Okay, then we have something called as NOT. Okay, NOT means not whatever it is. Okay, so it takes NOT will take only one value, not true value. Okay, so let's say if I do here and I have to, so the mathematics, like just like mathematics, here also these operations follow a BODMAS rule. Okay, first bracket. So if you put this in the bracket, this will be executed first, and then I'm saying not. So the exclamation mark is sign for not. Okay. Okay, this is a not. So whatever the output is there, it will do the reverse of that. So here 10 greater than 5 is true or 5 not false. So true or false is true, not true will be false. So when I run it, you get false here. Did you understand this? We will talk about it, when we start doing programming. Still, we are trying to understand some of these operations. Yes.
Yeah. Okay.
Okay. Great. So okay, so we have just completed logical operations also. Okay, and logical operators are and, or, not. Okay, we also have something called as double and double or. Okay, so if I say print 10 double and 5, okay, no, sorry. This has to be logical, right? So this, and I say this 5 equal to 5, let's say. Okay, so here you see there is no change, no difference, right? It is same as doing single ampersand, right? So 10 greater than 5 is true and 5 equal to 5 is true. So true and true is true, right? So there's no difference. Difference you can see is when instead of a single number, we will use a data type which has multiple numbers. So we'll talk about a vector. Okay, so I'm going to say vec1, let's say. Okay, vec1 equal to, see, this is how we define vector. C of, let's say 3, 4, 5, 6. Okay, and vec2, the second variable, I'm creating vec2, and this I'm saying, okay, 10, 5, 2. Okay, right? And okay, and just thinking like what operator should we do it. See, one way to do that is instead of numbers, what I'm going to do is let me put the output itself, because if I use numbers, I'll have to create 4 more, right? For and all those things. Let's say I don't do that. I create true. I put all true here, and I put true, and true. Let's say I put all true here. Here I give false, true, true, false. Okay, so see what true means technically speaking is if value is there, it is true. Value is not there, it is false. So if you give number 0, it will treat it as false. If you give number 3, it will treat it as true. Okay, so let's say I have got 2 vectors, true, 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 and here you have false, true, true, false. Right now I give print. I will use single and both double ampersand, both I'll use. Okay, so I'm going to say vec1 and vec2. Okay, so when we use single values, there is no difference, right? We didn't find any difference. But when you pass multiple values, let's see the difference. Okay, so first let's run this first one, single ampersand. Sorry. So we have to run vec1, vec2, right? I did not run it. So vec1 is run, vec2 is run, and vec1 and vec2. So see, what it did is it took each member of the vector and performed AND. So true and false is false. True and true is true. True and true is true. True and false is false. Right? So it performed all the operations individually. So if your input vector has 5 variables, output will also be 5 logical values, right? But let's see when we perform double ampersand, what happens. It will get only the first occurrence. Okay, though you have 4, it checks for the first one. First one is first true and right, true and false is false, so you get false. It does not check rest of the values. First value. Okay, if I make this as true here, okay, so only vec2 have changed, so vec2, and you see you get true. Well, the first output is taken and used it. So you have to be careful when to use double ampersand and when to use single. Single ampersand will perform element wise operation, but double ampersand will only do the first element. Okay, it will ignore the rest as if it is others are not there. Did you get it? And same thing happens with
Yes.
OR. So for single values, you won't find any difference, but for vector, you will only see the first one. So here I'm going to do OR, the pipe symbol, okay, which is just below your backspace or above enter. This is pipe, and you can use double pipe. Okay, so single pipe and double pipe. Okay, that's the difference. First output is shown. Right? So these are your logical operators: ampersand, pipe, exclamation mark, double ampersand, double pipe. Okay. Then we'll talk about assignment operators. Okay, assignment operators we've been talking all 3 days. Okay, it is important. So let me repeat it once more. A equal to 5. Print A. Okay, A equal to 5. Was there a question there? Your voice is breaking. I'm not able to hear you. Your voice is
So what
breaking.
is the right now? Is it okay?
Yes.
Hello.
Yes.
Hello.
Yes. Yeah. Go ahead.
Yes. So as we see, there is a single and double AND is there, right? So single AND it's perform all the data, but for the double AND it's perform only the single data, right?
First data.
So what is the point of having like first data? So what is the point of having like double AND? I mean, if you wanted to just do for the first data, you can just only put the first data. So there's no point of putting all the data and just perform only the single one.
Correct. So see, again, it depends upon the usage. Now, if I want to get only one, okay, one value, and if I run the ampersand, it is going to give me 100 output as output. Okay, if I have 100 elements, for example. So how do you manage? Managing 100 is difficult, right? So when to use it, how to use it. Okay, that's what is important. Okay, these are the capabilities. R says this is what I'm giving you, right? Now, how do
Okay.
you want to use it? It's totally up to you.
Okay.
Right?
Got it.
These are the capabilities, right? These are the capabilities that you have. And if you don't feel the need of using it, it's fine. Don't use it. Okay. Okay. So, okay. And see, because I told you earlier also, right? R finds a lot of usage. Okay. There would be situations where you will deal with such values and you are interested only in one. You say, okay, let me use only double ampersand. I don't want to use single ampersand.
Okay.
Okay. Yeah. It's all about the situation. Okay. Okay. So assignment, when I say a equal to 5, I'm assigning value 5 to a. I can say a 10. That means, see the arrow. Okay. A less than hyphen. Less than hyphen is like an arrow pointing towards left. Isn't less than hyphen is the arrow pointing towards left. It means move 10 to the left. Move 10 to a. So now if I print a, I will get 10. We have one more thing. A less than hyphen 20. Less than hyphen, arrow with double head. Okay. This also is assignment. Okay. Now if you print, okay. Probably because we have not run the other thing, right? So let's select everything and run it. Okay. So see this? Okay. Arrow less than hyphen is also telling go to the left value, go to the left variable. Double head hyphen also tells 20 go to a. Okay. Similarly, you have 100 going towards a. Now here hyphen greater than, that means move towards right. In this case, the variable name which will accept should be on the right side. Okay, this capability is not there in the mathematics also. Mathematics also, the y will always be on your left, isn't it? We perform on x on the right side, but always we say y equal to, we don't say 5 equal to y, we say y equal to 5, right? But R gives us the capability where we can say 5 equal to, okay, 5 equal to y. Okay, so a 100 moving to a, 100 going towards a. Okay, and if you print a, okay, we'll run this first. Okay, and then you can even say 200 hyphen greater than a, and print a. Okay. Okay, you see that a is 200. Okay, so it is that we have seen 5 ways, right? Still yesterday we spoke about only 3 ways. Now you see there are 5 ways. Okay, arrow with double head is also we can use to assign. Difference between all these, we'll do it when we start doing a program. Okay, when we come there we'll do it. Okay, but for now, okay, you know that we have 5 ways to assign a value to a variable. Okay, there are some miscellaneous operators as well. Okay, we call them as miscellaneous. Okay, so we have something called as colon. So if I say print 5:30 colon, okay, double dot, it will print a number from the number that we give to the number. So if I say 5 colon 30, it will start from 5 and 5, 6, 7, so on up to 30. Okay. So if you want to print 10 numbers in series, you don't have to say 1, 2, 3, 4. Okay. Directly you say 1 colon 10 and it will print 1 to 10. Right. So colon is very powerful. It can generate values, okay, from given number to the other number. Yes. Then we have one more operator called as in operator. Okay. Now in operator checks if a value is in a particular list or not. Okay. So let's say I create a vector, vec1. Okay. Now let me use it like this to assign the value. See, and I say 10, 20, 30, 40, 50. Okay. So vector is a variable which has 5 values. Okay, 10 to 50. Now what I'll do, I'll say print, okay, 5, okay, 5 percentage in percentage, percentage in percentage, okay, and I say vec1. So it's like asking, is the left side value in right side? Is 5 in vec1? Okay, is 5 in vec1? So let me run vec1 first. Now you see when I run the second line, what happens? Okay, false. 5 is not in vec1. Instead, if I make it 50, okay, now I run it, it is true. So in percentage is like asking a question. Is 50 in vec1? If 50 is there in the vec1, you will get true. If it is not there, you will get false. You can even use a colon here. Okay, so print 25 percentage in percentage 2 colon 50. Yes. So 2 colon 50 will generate 2, 3, 4, 5, 6, 7, so on up to 50. So is 25 in 2 to 50? Yes, it is there. So you get true. And instead, if I make it 250, of course, it is not there, right? So it will, you will get false here. Right? So these are some of the operators. Okay, so last 2 days we have seen different operators, okay, which are used, okay, by R to perform different operations. And now what we'll do is we will get into programming. Okay, so last 3 days we were just trying to understand about our different capabilities at basic level. Okay, what it had. Now we will get into programming. Are you all set? Any questions
Yes.
so far?
No.
Yes, sir. Also.
No? Okay,
No.
good. Okay. So the first, okay, so what we have seen so far is when we write these lines of these lines of code, okay, so we saw how to run using run, right? And source, if you want to run everything, you click on source. Okay, it will run entire, if you have 42 lines, it will run all the 42 lines. Okay, so you click on source and you run it, it will run all the, okay, so whatever statement we have done, all the output is displayed here together. Okay, so what we have seen is when you run a program, okay, it will execute in a sequential fashion. First line number 1, then 2, then 3 and 4. Yes, RStudio gives us the capability to go or to move around, right? But as a program as such does not have the capability. Okay, program will make you go through, R program or Python or C++ will make you go through line by line. There are some conditions, okay, based on which sometimes you may not want to, okay, go line by line. So example, let's say let's say there's a school grading system and they have some grading concept like this. Okay, if you score more than 80%, you get grade A. 60 to 80, you'll get grade B. 40 to 60, you get grade C. Okay. Then 20 to 40, you get grade D. And 0 to 20, you get grade E. Let's say you have these 5 grades. Okay. Now I want to print using program the grade for the student. Okay. So you will take input AVG as, let's say, 56. Okay. So AVG is 56. Now I need to print grade based on this average, right? So technically speaking, all 5 lines of code you have to write, isn't it? A, B, print A, print B, something like this. Print grade A, okay. B, C, D, E, right? So I'm saying grade E, D, C, B, right? So, but even if you get 56, all the 5 grades are printed. How do we hide some statements? In this case, I want to hide 4 statements, right? And print only 1 based on some condition, which is average condition. So I need to check the value of average and hide some statement and not unhide one particular statement. Okay. So in such cases, we use something called as if. Okay. If, okay. Now this if concept is there in all the programming languages. Okay. C, C++, Java, Python, and R. The way you'll implement is different. Okay. The way you will implement if varies. The way you do it in Python is different than what you do in Java, is different than what you do in JavaScript, will be different than what you do in C++, right? But the concept is exactly the same. If you want to, okay, control a particular, flow of a particular program, you don't want, okay, some lines to be printed, but you want some lines to be not printed, some lines to be printed. Basically, that's what I'm trying to say. So we use if, okay, and if is based on some condition, and the condition will have to use logical operators. So the output has to be either true or false. Okay. Now you see the usage of logical operator that we discussed is here. The output should be either true or false. So if works on true or false. Okay. If works on true or false, the condition that we give should either return true or false, nothing else. We can't use any other option there. Okay. So in this case, what I'm going to do is I'm going to say if, okay, if AVG greater than equal to 80, right? So if AVG greater than equal to 80, and this condition we can put it in a bracket. So if condition, okay, then we use this flower bracket. If condition in a bracket, open curly bracket and closing curly bracket. This is the rule of writing if condition, and if that condition is true, then perform something. Okay, when you say perform something, how will program know that how many lines of code it has to perform, right? Which lines of code needs to perform? So everything that you want to perform, if average is greater than 80, should be here. Every line of code that you want to execute, if the condition is true, should be inside this. Okay, in our case, we have only 1 line of code. Fine. Okay, as we build our complexity, we'll type more lines of code. So say print grade A, or you have got grade A, whatever you want to print. You have got grade A. So if AVG is greater than equal to 80, print you have got grade A. Okay. Now in this case, average is 56. Okay. And when I execute this line of code, you get no output. right? Because the condition became false. AVG is 56 and you're checking against 80. So 56 greater than or equal to 80? No, it's not. False. If it is false, then the if block will not be executed. If block will not be executed. Okay. Here, if I say 86, now I come here and I execute it. You see, you got grade A is printed because 86 is greater than or equal to 80. So this condition became true, and when it is true, it will go and print it here. Any questions so far? We are slowly increasing our complexity. Okay, if you don't understand, please stop me and ask me, because the next thing that I'll talk about will be even more little more higher in complexity. So if you don't understand, you want me to repeat, you want me to tell you in a different way, please let me know. Okay, because we are all here to learn. Okay, be shameless in asking questions. It's nobody is worried about you. Okay, you have to worry about yourself. If you don't understand anything, stop me, ask me. Any question here?
So is there like any connection between that print above, which is like grade A, B, C, D,
No,
with print?
there is no connection. Okay, so see here, this is sequence, right? Now if I go and I click on source, what will happen? So line number 38, 39, 40, 41, 42, okay, 45, 46, 47, 48, 50. Okay, so this will be printed because I've given print without any condition. When I didn't put any condition, okay, it is all part of the same main program, right? Which is starting from line number 1.
Okay.
So it got printed here. After
Okay.
50, we have if, so it's checking, and that's why you got grade A. Okay, so there's as such, okay, there is no connection in programming world. The next line will not have a connection with previous line until unless you want it to have, right? There is a connection between AVG here and AVG here because I wanted to have. That's why I copied that AVG. Okay, otherwise there is no connection.
Okay.
Right? So meeting will end in 10 minutes and we will stop. Okay, whenever meeting ends, we will not join back again, guys. Okay. So we'll continue.
Okay.
We'll continue for 10 minutes, and whenever it stops, we'll see you tomorrow. Okay. So any question? Other than any other question? It's very clear. Understood, everyone?
Yeah.
Perfect.
Yeah.
Perfect. Okay. Okay. So when you have to check for one condition, we use if. Okay. If AVG greater than 80, you do something. Okay. Whatever you do, the something that you said has to be within the curly braces. Okay. It has to be within those curly braces. Okay. Now I want to do one more thing. I want to have two conditions. If it is greater than 80, I want to do this. If it is not, I want to do something else. Okay, something else, that's the key. Else curly bracket open and close. It means if it is not greater than 80, then do what? You can say else print you have not got grade A. Okay, so if AVG is 86 and I'm checking if AVG greater than 80, it is true. Okay, so when you have if else, only one part of this will be executed. So since here our AVG is greater than 80, so this is true and you get this part got printed. Okay, the other part is like else condition will not be called. But if I make it 56, okay, so the if condition has become false and it goes to else now. Okay, you have not got grade A. So if we have to do two conditions, okay, that means if condition is met, do something, and if doesn't, it doesn't meet, then you do some the else part. So if can exist alone, it can exist with else also. Okay, it can exist with else or without else. So when you write else, this whole thing is one single part. Okay, if I write another if, for whatever reason, this if is different than first if. Okay, there is no connection between this if and that if. But if I write if else, that means there is a connection here. These two, this together forms one single statement, in fact. Okay, now instead of you have not got grade A, what I can do here is in this else. So if it is more than 80, it will print this, and the else is anyway ignored. But if it is not more than 80, if condition becomes false, it will go to else, right? And what I can do here is I can say, I can put another if. This if is different than other if because if is a different block. But what I have done is I'm putting this if inside the else. I put this if inside the else. So it is part of this else, and this if will be called only when else is called. And here, since AVG is not more than 80, I know AVG is not more than 80 because if it is more than 80, it will never come here. It will go to the line number 54. If it is less than 80, that's when it comes here. And I can do another check. Okay, I can say AVG greater than 60. And I'll say print you got grade B. Okay. Now, okay, I can put another else for this particular if. And I can say print you have not got grade A or B, right? Okay, instead, what I can do is I can do another if. If AVG greater than 40, I'm going to say print you have got grade C. Okay, so if else, okay, let me try to design something pictorial. So I'm forming a condition here. If and else. Within this else, again I'm doing if else. Again in this, again I'm doing if else. So we call it a nested if inside a if condition. If inside a if condition, right? So what I want, what I want to do is I want you to complete for D and E also, and let's see. Okay, you complete. I have this is incomplete here, right? We haven't handled D and E. Please complete this program, okay, today or tomorrow before we meet, to handle other two grade as well. Did you get it? Can you do that, everyone?
Yeah.
Yes.
Yes, great. Please do that. If you can't do it, we'll discuss it. Okay, ask me tomorrow. Okay. Otherwise, do it. Okay, if you're not going to do it, please ask me. Okay, great. What Python says is, Python says, okay, this is good. You can do if else, nested if else. But Python also provides an option called as, okay, if else if else. So, okay, this is second way of implementing. Same thing I'm implementing in a easier fashion. Okay, so Python I'm saying. Okay, so R. Okay, R gives us this capability as well. So if AVG greater than equal to 80, right? You perform something here, say grade A. Okay, now what it says is, instead of else, you can also use if else. Okay, sorry, not if else if. Okay, it says you can use else. So see, if you have to check one condition, you will use only if. If you have to use two conditions, you will use if and else. If is the condition is true, else is default. Okay, if is not true. If you have to check for 3 conditions or 4 conditions or 5 conditions or 6 conditions or 100 conditions, we can use else if. So first is always if, last one is always else, in between you can put any number of else if. So if you have 100 conditions to check, your first one will be if, 100th one will be else, and in between 98 will be your else if. In this case, we have to check for 5 conditions. So first one I have checked for grade A is if. Here I'll say if, okay, else if AVG greater than equal to 60. Okay, and you can put your thing here, print grade B. Okay, and here again you can say else if, okay, AVG greater than equal to 40, print grade C. Okay, else if AVG greater than 20, print grade D. Okay, E, we don't have to give else if, else. Okay, if every condition above is false, then you simply say grade D. Okay, this session is about to end. Okay, we will talk about it detail tomorrow. Okay, don't worry if you don't get it, we'll again revisit this tomorrow. Okay, so what I have done, I've started with if 80 and I'm saying grade A. Okay, if this is false, only then it will go further down. If this is met, if our AVG, let's say I put AVG here, if I say AVG equal to 89, okay, so this is true. Okay, only this part will be executed, these parts will be ignored. If I say 79, so this will be false. If this is false, it will go and check for next condition. If first condition is false, then only it will go to second condition. If first condition is true, rest of the condition